For the problems we've been talking about with field scheduling, those spreadsheets are inherently not very good. Right?
No,
There are other
no.
scheduling problems that are simpler and that you can do really well with a kind of manual or kind of heuristic approach. But the field scheduling problems, the complexity, the combinatorics are sort of insane.
Yeah, it's completely insane. We had this Christmas quiz where we said, okay, it was a very simple problem. It was actually just a traveling salesman problem, like 20, 30 spots on a map, try to find the shortest route. 30 engineers, smartest people I know, couldn't find it, right? And
Yeah.
how can you solve something with 1,000 spots on the map where you can send it to 50 different technicians, 100 different technicians, and then you have all of these other constraints that come into account that just make the problem even harder, right? It's inhuman.
Hello, and welcome to another edition of the Decision Intelligence Lab podcast. Along with my co-host, Michael Watson, I'm thrilled to welcome Geoffrey De Smet as our guest today. Geoffrey is the co-founder of Timefold, something we're going to get into and talk about quite a bit today. So without further ado, let me throw it over to Mike to get us started.
All right, I'm going to talk about the big problem that you tackle. So what is field service routing and why should we care about it?
Yeah. So field service routing is a form of the vehicle routing problem where we need to send a number of technicians or home care nurses or pest control people, doesn't really matter, to a number of locations across the country to do a number of jobs across the region and things like that. So for example, let's say a home care nurse needs to go to 5 locations. And of course, you need to assign each of those jobs to one of the home care nurses, and you need to assign them also the route in which they will do the order in which they will do this. And so with field service routing, we do that with thousands of visits, tens of thousands of visits in a data set, right? And we assign all of these to at least to exactly one person to go there, and we decide in which order they go there to optimize the route. Now, the difference with the normal vehicle routing problem is that it's not just about optimizing the route and taking into account the time windows, making sure that they arrive there at the right time, that there's somebody there to open the door. We also take into account things like SLAs. They need to be there for a certain time. Things like skill requirements. You want to make sure that if you send a plumber, and for example, if you need an electrician at a particular job, that you don't send a plumber to that particular job, right? We take into account seniority of the skills. We take into account the fact that you can schedule a job on Monday, Tuesday, or Wednesday, and some of these jobs, especially maintenance jobs, doesn't really matter which day you go. So you want to go there when you're in the neighborhood. So for example, when I need to show up, down the street on Tuesday because I've promised my customer to go there that day, but you have maintenance in that street, you want to actually do that work on the same day, right? And that's a little bit all kinds of things you can see in a field service routing case.
Perfect.
So I'm fascinated with these service operations problems. I spent a lot of my research career working on call center problems, and vehicle routing always felt harder to me. Can you say a little bit about, I guess there's 2 areas I wanted to probe into. One was around uncertainty. And what are the components of uncertainty, and how, I guess, part and parcel of that, how do we then deal with updates and evolution of the plan over time?
Yeah. So the first things first is that whenever you create a plan the day before, it's never really going to go in execution the way you planned it, right?
Yes.
But there's a quote around Churchill that I like, and he said, like, plans are useless, but planning is
Yes.
essential. And it really brings down to the fact that if you don't have a plan, it's going to become chaos. But if you have a plan where you try to be as accurate as possible, you're going to have a good starting plan, and then during the day it will change. So one of the things we support is we first to go for that perfect optimal plan, right? That's when we solve for 30 minutes if you have a very big data sets and things like that.
Yes.
But then during the day, you're basically in survival mode. Somebody's trapped in an elevator, and one of your elevator technicians needs to drop everything and get those persons out of that elevator, right? There's no debate around that, but you then need to figure out who's going to do that, right? So you need an answer immediately. And that's where we can do, we run warm start. So basically, we take the solution we had that's being executed, and we calculate, okay, if we make this problem change, we now need to send somebody there immediately. Who is the best person to send, and how will this affect the rest of the plan? And this is basically what we do during the day, right? And that's how you can change how the reality as it shifts and as it changes from the original problem statements during the day, right? Now, taking into account uncertainty is the next step. Now, there's a big problem with taking into account uncertainty. The first problem is that most companies do not have like distributions on their the uncertainty. So, for example, if you say it will take on average 2 hours to do that job, right? Very few companies will actually be able to tell you, like, okay, but it's not a bell curve. It's more like towards it takes on average like an hour and a half, but some cases take 8 hours, right? So without that
Right.
data, you're dead in the water. There's no point in like doing stochastic optimization and things like that. When you start taking this into account, you can, of course, make sure that, like, a couple of constraints we do to deal with uncertainty is in field service routing is the last visits are never priority visits. So if you say, for example, I need to do this visit today, we will actually make sure that happens in the early part of a technician's route. Because the early visits are always done. It's always the last visit that's like more like a 50-50 case, whether there will be enough time to do it or not, right? So that's how you put in these kinds of requirements to make sure that you skew it towards a case when uncertainty hits, when things don't happen, that it actually works out fine, right? Now, on our solver level, we can actually deal with deeper uncertainty when you have these kinds of curves. We can have a lot of freedom here. We can start adding these kind of things in there. But I'm not convinced it's a practical thing to do today. I've not seen it in production, and simply because the data is not there. That the companies do not have the data in most cases.
And do companies tend to buffer the times? So,
Yes.
they'll tell you like, I think it's 2 hours to do this job, but let's plan for 2.5. Or is
Yeah.
that another solution?
Yes, and you see a lot also with travel time. Like we say, okay, we take the travel time, we get it from the maps data, right? So we integrate with real maps data, so we know it takes about 2 hours to get from A to B. But then they add in 5 minutes everywhere because it takes 5 minutes to park, right? And then of course, if you start dealing with traffic, then the next level comes in, and you need to take that into account. But they add in buffer times. And sometimes also on the jobs itself, of course, right? Just to walk in
Okay.
the door, to say hi to the receptionist and things like that.
So basically, if everything goes right that day, your technician is just done early. Like
Yes.
every stop was fine, traffic was good, and you're just done 2 hours early. And then some days you're pushing the limit and you can't get to the last stop.
Yeah, but if the job is done 2 hours early, they do that real time scheduling, that warm start, right? And they get new jobs and they start assigning them. Don't worry about that.
Okay.
They keep them busy until
Okay.
their day is done.
Yeah. That's what I was going to ask too. Do you rerun? Like, do you have a plan for tomorrow, and then by noon you rerun it because
Yes.
everything's off? These 2 jobs took too long. These 2 jobs were fast. Is that what tends to happen with these companies? It's kind of almost a
Yes.
real time system.
Yes, yeah, and we even have an API for that we take into account the diff on the original problem. So if you send in through the entire problem again, if you have 10,000 locations, that's a big data set, right? If you just send in like, okay,
Yes.
these jobs took longer, this happened, right? You can actually just send in the diff, and that's faster. Yeah. The thing is, in that point, it's really a race against time. When the plan is executing, you cannot take 5 minutes to do to schedule to find a solution. You really have to do it in seconds, and it's really survival mode. It's not about perfection anymore. It's just doing better than what a human would do in this head, right? If
Right.
that makes sense.
And I guess there must be some constraint too that says you're in the middle of the day, minimize the number of changes to sort of
Yes.
satisfy this problem. Is that
Yes.
true?
Yes, non-disruptive replanning, basically. So for
Mm.
every change you make, you can impact the soft score, right? Now, the first thing you do is you also have to pin things. So, like the things that happened in the past, you cannot change the past. You cannot just say, if you have a new optimal plan that says this morning you should have done this versus that,
Right.
that doesn't work. So you pin all of that. You also pin. This is an important trick. You also pin every person that's already traveling. So if you have like a technician that's already en route to a particular job, there's no point in trying to change that. It's just way too disruptive. In some cases, they even pin up to 2 jobs in advance already, and so they say you don't change those anymore. Just do everything after that, right? And that works because the solver basically says if it's pinned, I leave it alone and I work around. I can change. I can only change the other things, and I will work around what you forced upon me, basically, right?
And presumably with some penalty for sort of shifting from a current plan.
Yes,
Right.
indeed.
Right.
The combination of pinning is hard, while making it disruptive, making disruptions, making changes is that soft penalty. Yes.
Yeah. Do
Yeah.
you connect to customer service like apps too that like will call and alert the customer like when the vehicle's arriving or when the technician's arriving? Because I think, from you get complaints, the consumer will complain, right? If you give this long window and then you miss the window, and it's like, yeah, there's a lot of math that goes on behind that. But and so you must link up with those kind of systems too, right?
So we don't do the linkage directly itself. So our API is simply you send us the scheduling problem, we solve it, and we send you back. But really notifying the execution, that's for downstream systems. That's typically your ERP systems, think like an SAP or think like Dynamics or things like that. So we don't do that part. We just do the scheduling part. That's the part we're really good at. But of course, we do see input from them coming back. Okay, that technician is late. It's now he was supposed to finish at 10 o'clock. He's only finishing at 11 o'clock, or things like that. And we take that along in the plan to make sure we optimize for reality and not for what we think is a reality. Right?
Yeah, and I guess your system is also like once your system's in place, it's also probably a good benchmark to start collecting that data. Like now they have a way to say this is what should have happened or what we thought would happen, and this is what actually did happen, so you can start to track technicians, types of jobs, things like that.
Yep. And
Nice.
that's where it gets interesting, is something we call what-if simulations. So once you start tracking reality, you will see that this is the constraints as a business they said we need to follow, and then you see how that actually plays out in practice. And so, for example, I talked about that priority thing earlier, right? You say, oh, you should not do priority 1 things after noon. You should not do priority 2 things after 4 o'clock. What you can actually do is you can then start running simulations in our platform and say, okay, I'm going to take that data set, I'm going to make some changes to it. What if we, break that constraint? What if we lower the importance of that requirement? How does this affect the schedule? And the same thing you can do with those schedules coming in from how they were executed. You can use that information to basically tune your weights, to tune your constraints better, to do real multi-objective optimization, basically. Right?
Yes, that is, tuning is a lot of work, but
Yes.
it definitely has huge value.
Yeah.
I'm interested, Geoffrey, in kind of where the user of your product, I imagine, is a dispatcher, right?
Actually,
Or say more.
So it's software builders that use our APIs. So our REST API, for example, for field service routing, and they put that in their application. It's either a based homegrown application. Typically in enterprises, we see that a lot, or
Yes.
it's an off-the-shelf field service routing application that says, okay, you can do manual scheduling in here. You can drag and drop work to resources, jobs to technicians. But we now want that schedule with AI button, and then when you click that button, it comes to us, right? So we typically help the software builders, not the dispatchers directly. Of course, they are the end users and they get the real benefits, right?
No, that's a really important distinction that to think about Timefold as developer tools at the core
Yeah.
of it.
Yeah.
And so now I wanted to take further. So the developers, are they typically IT folks? Are they OR folks? Are they traditional data scientists? In what what is their perspective?
That's a good question. Traditionally, it's more IT folks, and this is really from the history of Timefold. So we didn't start out as an operation research project. We started out as an engineering project. When I started building it 20 years ago, I think it took me maybe 5 years or so to even understand that operations research existed, even though I was building a solver for that the first, back then. It's maybe a bit embarrassing to admit, but I'm pretty sure it was like, and you can see that in the design of the solver. So it's never been based on let's have people write mathematical equations to formulate the constraints. It's always been what would be the easiest that a programmer, a 9-to-5 blue collar programmer could understand and could do, right? And still meet all of the business requirements, right? And it's really that mindset that's been built. And you can still see that in the design today. And that makes it easy to use. That makes it scalable. And it makes it easy to integrate. That being said, there's a lot of knowledge coming from the operations research world. So we've definitely integrated that too. That's where the real, the deep algorithms come from, like, similar annealing, tabu search. Many of these algorithms, we've all incorporated them over the years, right? But we're trying to blend the worlds, and we're really trying to get that operations research thing that's so powerful, but that's so difficult to use, to bring it mainstream, to really because it's existed for so long, but it's existed for more than 30 years. Like Cplex was released more than 30 years ago. But if you look at today at how schedules are made, the vast majority are still being made manually, like even in Excel, or in this scheduling, drag and drop scheduling apps. And the projects that tried to automate it, many of them has failed and it's because it's simply too hard to use, too hard to integrate, and that's what we want to fix, basically, right? If that makes sense.
And so when we were discussing this before the call, you talked about maybe there was 1 million calls a day, a year to your solver, like, and then you mentioned it's a tiny fraction of the market. Like, how big you think the market is? Like, how many people are out there that have this field service routing problem that could be using this technology and aren't?
Yeah, and this is just, and we handle any kind of scheduling problem. But just looking at field service routing, I'm
Yeah.
amazed what people do with it. Like, I thought it was just telco technicians, and but people are fixing railroad with it. People are doing pest control with it. There's these companies that every X amount of time they need somebody of pest control to come around. Um, that's our all routes, and those
Right.
do multiple jobs on a day. You can optimize those. You can save 25% travel time there, which increases their productivity by 10%. That's these numbers, the amount of money you can save. I was involved in the case for telco. They didn't save millions of dollars; they saved hundreds of millions of dollars with this per year, right?
Per year.
So
Where'd it come from in the telco case? Does it come from vehicle miles? Did it come from labor savings? All of the above? Like,
mostly labor savings. So
mostly labor. Okay.
yeah, fuel consumption, of course, has a big impact too, especially these days. But mostly was labor savings. You were highly skilled workers. They actually ended up doing the same workload with about 10% less people. Now, I've actually seen the opposite. Like government inspection, school inspections is another field service routing case. I've seen a case there, and they say, okay, we can actually save on the number of inspectors we have, but we don't want to do that. What we want to do is we just want to have longer school inspections, right? And if you change the game like that, then you create better service quality, right? And so it all depends on what you want to optimize for. Usually that's a win-win, but of course, in some cases they just purely flat out go for cost efficiency, and that's why you want to do the what if scenarios to
I like
show.
it. Yeah, right.
Yeah.
Because you have a trade-off curve, right? You could either provide more service or do it
Yes.
cheaper. And you can
Yes.
in some businesses you can make that decision. Yeah. Okay.
Yeah. And that's where the what if scenarios are so interesting on our platform, because I can really see, like, for a little bit of less cost reduction, you can increase service quality a lot more, or employee well-being, making sure that people don't drive out of their area that they like and do, or that they don't do jobs they don't want to do. There's certain skills or jobs level they say, this is below my pay grade, let's avoid those jobs. You can take all of that into account, increase your employee retention, make your employees happier, and that's of course also better for your bottom line in the long term, right? And so it's important to quantify those results too.
And I assume in some businesses there's constraints or rules that say, like, I'd really like the same technician to visit the same place over and over again, or there's preferences for technicians. I'd like to go in this direction. I'd like to go north rather than west. There's things like that. Are those things that you see in your customers?
Yeah, like ratings. Technicians have a rating, and you need to prefer to send technicians with higher rating, but also like to gold customers, you need to send the ones with higher ratings because you really don't want to lose those kind of things.
Okay.
We see things
Okay. So
like
it's a sales tool too. So it helps you drive sales and yeah.
Yeah, definitely. That's why that's why you want to tweak it. Like, okay, how important is this versus route optimization versus reducing overtime and things like that, right?
Well, I love the mission, Geoffrey, is to rid the world of scheduling spreadsheets. And for the problems we've been talking about with field scheduling, those spreadsheets are inherently not very good.
No.
Right? There are other scheduling problems that are simpler and that you can do really well with a kind of manual or kind of heuristic approach. But field scheduling problems, the complexity, the combinatorics are sort of insane.
We had this Christmas quiz where we said, okay, it was a very simple problem. It was actually just a traveling salesman problem, like 20, 30 spots on a map, try to find the shortest route. 30 engineers, smartest people I know, couldn't find it, right? And how can you solve something with 1,000 spots on the map where you can send it to 50 different technicians, 100 different technicians, and then you have all of these other constraints that come into account that just make the problem even harder, right? It's inhuman.
Yeah. Well, maybe we should change gears because Timefold has a very interesting founding. So, and it's got some open source solvers at its heart. Can you talk about sort of the evolution from your first product, OptaPlanner, as a open source product to Timefold, a commercial company?
And I want to add one more thing to the question, simply because of something you said a couple minutes ago, and that was, how did you come to the problem, and kind of did you start out by solving from first principles? You said for 5 or 6 years you weren't kind of aware of the OR literature. So I think to add to Mike's question around what's the history? Also, kind of what's the computational or the technical approach history as well?
Yeah. Oh, with pleasure. So back in 2007, I was working as a researcher briefly, and one of my colleagues there showed me a nurse rostering implementation, did a presentation around that. And so he was using the Tabu search algorithm, which is meta-heuristic, a local search, right? So it takes a solution, improves it and make sure it doesn't get stuck in local option. And that algorithm was pretty easy. And then he had thousands and thousands of lines of code to do the score calculation, to do the, calculate which constraints was broken where, which, do not put two shifts in the same, for the same employee at the same time, things like that. And because he needed that to happen incrementally. So incrementally means that if you have a particular solution of I assign these shifts to those people, right? That it actually, when it makes a small change, it can calculate the impact of that change, whether that's good or bad, without having to recalculate the whole thing, right? And that was thousands and thousands of lines of code. And I was looking at that code, and I was like, I think I know a way to generate that boilerplate code. That's boilerplate code to just get rid of all of that and just to specify this is my constraint and do that. I know some technologies was actually the open source technology. I can combine that. And so I started writing that and combining these incremental calculation with these meta heuristics, local search things, right? That was back in 2006. And so I did that for 7 years in my spare time. And this is the crazy part. After 7 years, the supplier to NASA was already using it. So they were scaling satellite bandwidth with software written by some guy in Belgium in his spare time in his 20s. It's completely nuts.
That's an awesome story. It's like it's what started as like a nurse scheduling problem. You were just going to clean up some nurse scheduling code, and then eventually in your garage, basically, or your upstairs bedroom, and then all of a sudden now NASA's scheduling satellites with it. I love it. I mean, it's cool.
It's insane. And then by 2013, I was already working for Red Hat on a couple of other projects there, and so they saw value in it. They had people asking for support for it. It was already used across the world.
And it was open source at this point. You open source this. Okay, perfect.
From day one, I just wanted to build something. I was not thinking of building a company whatsoever.
And so your background was in computer science and software development.
Yeah, I was a Java consultant for a while before that, and even after the research period too. And so I was just doing this in my spare time just to have fun, doing some academic competitions around vehicle routing and so forth. And then at Red Hat, they saw value in that. So my hobby became my work. They just said, okay, we'll start selling support on that. We'll pay you full time to just work on this. And I could build out a team. We ended up with 5 people, and then the big telcos and so forth started using us, and all kinds of other companies. And then, IBM acquired Red Hat. Red Hat's strategy changed, and basically there was no way to continue the OptaPlanner project there. So I had no choice but to build a company to continue my life's work. I've written a long blog post around that. You can see a little bit of the scar tissue in there. It's a wonderful experience. It's a horrible experience at the same time. You guys as founders probably can.
So just to kind of say, so now IBM acquires Red Hat, and now they're essentially trying to weed out projects and commitments that don't have a big ROI.
That's not how I would phrase it. What they're trying to do is they're trying to divide what does Red Hat do and what does IBM do. So there's no overlap. And somewhere along there was like this roadkill, which was OptaPlanner. It gets decided so high level up. The revenue of our project was not big enough for them to even know what it was, to put it like this, right? We had and so that's a little bit what happened. Now, the big thing there is, even though we had tens of thousands of projects around the world using us, we had more than 15,000 downloads per month, right? Even just uniquely the artifact that one artifact that everybody had to use. What we saw is that very few of those paid, like not 1%, not 0.1%, like 0.01% or something like that. That was enough to sustain us in the Red Hat days. Was not enough to actually build a company around, right? And so
Got it.
I realized that this is not going to work. Developers need to eat. We want to maintain the old team, right? And so because of that, what we did is we said, okay, we need to bring extra value on top of that. We also took a little bit from the open source solver away, high scalability feature, the explainability enterprise features, made those paying. You can still solve any scheduling problem with the open source solver, but we wanted to really offer something more for the people who are willing to pay. But on top of that, we started building those APIs, so those REST APIs, those models like the field service routing model and the employee shift scheduling model, where you just say, Instead of you having to say, I'm going to build my model for on top of the solver, the model is already there. You just send in your data and you get back the answer, right? And we saw a good way to build a company around that, basically.
So your model that you built for field service routing, for example, when you say model, what you built is your APIs say, like, here's all the input data you can use. You don't have to use all of this. Here's the different objectives you can have. You don't have to use all those. You pick and choose those, but you don't have to formulate the model. You just fill out this amount of data and basically check or uncheck these boxes. It goes to your solver, comes back with, here's what it comes back with. Here's the order, the routes, the times. Perfect. Okay. So that's total value for enterprises, right? They don't want to, their IT team does not want to build a model, debug a model. You're doing all that work.
Yeah, but what we've noticed, and this is the weird thing, it's good for mid-market. So mid-market, they don't want to build a model, right? Now, for enterprises, they're like, yeah, but you never know that we want to add something in there, and we don't even want to tell you what we want to add in there. So we'd rather build the model ourselves. So what we're actually now enabling soon is that you can take your model or one of our models and adjust it to your needs, and then say, I'm still running it with the Timefold platform. Because the Timefold platform, what it does those, what if scenarios, is explainability also for you. It integrates maps for you. It makes sure that if you send it 1,000 data sets, it does other orchestration for you. So all these kinds of things that you just need when you put stuff in production, right? Which your IT department will fuss about, basically, right? SOC 2 certification and all of that. Then it does all for you. So you can focus purely on, okay, I want to write a model, and what do I want to optimize? Vehicles, visits, nurses, whatever the case may be, right? And then you can adjust it to your needs. That's basically the direction we're going to right now.
If I read it back, it feels like there's been an evolution from what was originally a heuristic solver to now an application platform and a development environment for solving optimization problems. It's almost solver independent.
Well, that's
is it? Yeah.
No, it's not. So if you look, for example, at Nextmove, they've built also this platform.
Yes.
But they were completely solver independent, right? And so they don't come with a
from day one.
From day one, yes. Well, anyway, yeah.
Well, they had the little solver, but
okay. We've gone another route, and very specifically. So we actually integrate deeply between solver and the platform. So regardless of what model you put in between, whether that's for vehicle routing or for shift scheduling or for job scheduling of machines, right? Regardless of what you put in between, because you use the Timefold scheduling solver, the platform can query a whole bunch of things out of there. It can, for example, know what are your constraints. Are your constraints penalizing or rewarding? Very important. When you have a schedule, tell me the justifications where it broke what. And on top of all of that, we can build explainability. So we can tell you, like, these shifts will be impossible to assign. These shifts will be hard to assign. We can do comparison based upon not just the KPIs, but also the constraints. Like, we can say, we've optimized this data set, once for cost, once for employee well-being. We put them next to each other. You can really see the difference there, right? So because we know the solver, we can plug in so much more, and we can really extract those insights and so forth from it. But that does mean that you cannot, at the moment, plug in another solver and say, okay, I want that too, because that's really a black box. Most of them don't even support explainability. And this is something our solver support, but really, the solver has the seed, the fruit is in the platform, right? When you really expose it in the UIs, right?
So that's something I've been waiting, I feel like, for 12 minutes to dig into, this explainability question. It's the most interesting thing to me around kind of high complexity systems and users that are nervous about the math. That explainability layer seems so vital. Tell me kind of what your approach is to that. And of course, we can't go through an episode of this podcast without at least some reference to LLMs somewhere. And so tell me what your approach is to explainability and kind of how you imagine that might evolve or has evolved in the world of LLMs.
Yes, that's a good question. So first of all, there's not one technique to explainability. There's multiple, right? So in the ground, the real question is, okay, I have a schedule here. Why did it assign Anne to that shift? Right? Why did it assign nurse Anne to that shift? And so the real answer is because of all of the other shifts in SNP complete and and SNP hard and yada yada yada. Nobody understands that. All of your businesses run away.
Right.
So what do you do? Well, the first thing that they do understand is like, okay, we've assigned it there, and this is the penalty of assigning it there because Anne didn't want to do a morning shift, and yes, she's assigned to a morning shift, right? Second thing is you do is let me try assigning any other person to that shift, and let me show you for any of the other persons that that's actually worse. Like if you assign Bat, well, Bat is already doing a morning shift. If you assign Carl is doing an afternoon shift. That's too much work on that day. He will get more than 40 hours a week. So that's going from level 1, just doing analysis, what is the score, to level 2. Let me try to find other things and show you that all of those are worse, right? Level 3 is when they manually make a change. You check if it's better or not, and then um, on top of those, what you want to do is what if scenarios. So what if we make it more important that Anne does not get those morning shifts, right? What will, how will the plan change, and what will that cost us, right? So that's really explainability. All these levels one at a time, right? Where do LLMs come into the story? Now, LLMs cannot solve your scheduling problem for you, right? They cannot really tell you which constraints are more important than the others. Don't outsource your thinking to LLMs, please don't, right?
Mm.
What they're great at is when you say like, okay, I've done the experiments like this, like, okay, what if, I have 10% more work, 10% more shifts that need to be fulfilled? What if I need to hire somebody, right? And what kind of skills should I hire? In these cases, LLMs can take your data set and add those and change that data set, change the problem to simulate that case when, okay, we need to hire somebody, or there's a number of people more we can hire, and you can run that through the same solver on the same platform, all in parallel, and then you can basically see, okay, you can make a real deep explanation, like we should be hiring more for that, but because that will bring better schedules. So this is already going to what if scenarios, but this is really where explainability and what if scenarios start getting together. And when you show those results, you need to explain, like, okay, this is the impact on on cost reduction. This is the impact on employee well-being, and employee well-being is then split off in like overtime, all these kind of things. This is where this all really comes together, if it makes sense. But
Very cool.
you're 100% right that if you build the perfect optimization schedule and you cannot explain it, you will not build the trust with your users. We've seen that the hard way, right? We've optimized, it's optimal, and then if you cannot if they cannot make some changes to it, if they cannot play with it, break the schedule and see what the impact on that is, they will never trust it, and they will just it's easy for them to ignore it, right?
And I think part of that is because for us as optimizers, the world ends with the optimal solution.
Yes.
For them as operators, the world never ends. They're
Yeah.
constantly reacting. And so I guess this is my hypothesis I'm trying to verify with you, is that the absence of trust comes because they know that this solution is approximate
Yes.
given what we knew at midnight and when we
Yes.
created it. And they know that if they can't understand the dynamics, they're going to struggle with the response over the period of operation.
Yep.
Right? Have I sort of seen the problem correctly?
Yes, that's there. So the real-time aspect, basically, right? And I've seen number of other things. Now, the one big thing I've always seen is when you have a number of constraints, hard requirements to get a feasible plan, right? And you fulfill 90% of those, right? It's 100% useless, and they will just throw it away.
Yeah.
So let's say field service routing, you do everything. You get, you do the multi-vehicle visits, all of the things I've talked about, except for the skills. You send one plumber to an electrician's job, right? They just kind of throw it away because they look at it and they say like, okay, can we fix this? And of course, it's been optimized. It's impossible to fix. There's no other plumber available at that time for some reason, right? It falls apart like a house of cards. And then they just say, okay, that's been great, but I'll continue my way, in Excel or their drag and drop scheduling UI, right?
So I jumped to the real-time adjustment issue, but you actually talking here about fundamental feasibility.
Yes, yeah, that's and
But
you'd be
let
surprised.
me push on that a little bit, because I think there's fundamental feasibility that's like so obvious. Like you don't send a plumber to an electrician's job.
Yes.
But then I bet there's other feasibility that's that they violate on their own. If they had to make their own schedule, they would violate it, but they don't let you violate it. Or they're less tolerant of you. Is that true too? That you have to sort of balance this? Like, all right, electricians go to electrician's job. Maybe I'll squeeze in a little bit of overtime because that's what they might have done. How do you deal with that disconnect too?
I've seen that too. That they say like, "Oh, you're breaking feasibility." Like, and then okay, can you show me what you guys optimized? And we run it through our system, and they're breaking feasibility all over the place. But it's a less important hard constraint, right?
Yeah,
So
so, I mean, this is part of our job, I think, is to figure out which are the real constraints, which are the real physics of the problem, and then which are the like to haves, and then
yeah.
build that into our models.
Yeah, and the typical ones are the heavy soft constraints. So like, that's really important. We should really take care of it. And the more they stress it, the more I start asking like, okay, and do you sometimes break it? Yes, but we should really try to not break it.
Right,
Then
exactly.
it's a heavyweight soft constraint. It's one of those soft constraints that get like a weight of 1,000 that overrules all of the others, or even as a medium constraint. So it's always
That's
more important. But
right.
yeah,
There's this hierarchy of constraints. I like it. Yeah, that's a good way to think about it.
yeah. Lexicographically, right? Yeah.
Yeah. Well, let
So
me change topics, and I know we're kind of coming up to the end, but I want to come back to your starting your company. You said something that I like to talk about when I talk about with people who want to start their own company. You have a section in your thing called the leap,
yes.
where at some point you have to make a decision to leave a job with benefits, nice steady salary, and jump into something where you have no idea where the next paycheck's coming. Talk about that for yourself.
So for me, that was a problem. But that's really for my personality. So, the I'm here we're here in an AI hub. We have an office here, right? And so half the company, we're 40 people. Half the company is over here. And when you
Yeah.
talk to any of these other founders, they will leap, eyes closed, without a doubt, right? But I'm one of those people who wants to think a few things through now. In my case, the technology was there, it was open source, we could fork it, right? So this was my life's work. There was no other conclusion than just to make this jump. And I even have in the blog the story of when I talked to my wife, like, I'm thinking of doing this. And she just replied, yes, go for it. You got a year, right? And that's just because she's awesome, and she made that decision much faster than me. But the leap thing is she also put a deadline on it. Like, you have a year.
Yeah.
Then free time is over, right?
Right.
When push came to shove, like, okay, we work things out, but at some point you just have to take the leap. It took us 6 months to raise an investment, right? And this is normal. And so that was 6 months living off savings and just seeing every month
Right.
The savings go down.
Yep.
And that's yeah. I'm sure you done something. You had the same
Same
leap.
experience.
Yeah.
Yeah, I think you said it well too. Even a year sounds really long to give yourself, but it feels like that's even short. It's almost like if you do the leap, it's like you gotta give yourself more than a year before you start looking for something else or give
Yeah.
up.
I'm sure I had still negotiation room, I think, but it all ended up well. So
Yeah, I mean, if you got some funding in 6 months, it worked out. Yeah.
we cheated, right? The normal startup has to build a product and then build a go-to-market. We had a great project already. We just had to productize it a bit more, and we had to build a go-to-market from scratch. That's really our
I don't know. You're
challenge.
underselling it a little bit, because in your blog post you talked about the fact you had no way to make money with this great product that you had. So you
Yes,
talked about that.
that's true.
So that's a problem too. Don't undersell yourself there. That's not easy.
Even today, they still have a lot of people that are like on OptaPlanner on the communities. It's all fine, but even people are still sticking on the OptaPlanner edition.
Yeah.
It works. Why change
Right.
it?
Exactly.
Well, I would say for security reasons, but anyway.
Okay.
The last question, perhaps, is can you just tell us a little bit about your go-to-market strategy? Is it a kind of product-led growth? Is it a kind of enterprise sales? What's your approach in kind of what if you feel like you've solved, and what are you still working out about your go-to-market?
So go-to-market is definitely one of our biggest challenges, right? And so what we have is we have a lot of people using our open source solver, and some of these say, okay, we see you guys have the APIs. We actually want to solve that problem. Let's just use the APIs, right? So that's how we bring in to those field service routing and application scaling APIs. That being said, go-to-market is a matter of execution, right? It's a matter of getting the right website. We're actually rebuilding the website as we speak. So and I think it's like the 4th or 5th time already. So there's a learning process there, I'm sure. And yeah, it for us it's definitely our biggest challenge. Like on the product side, things just work reliably. Like I said, we have actually more than 1 million visits per week being scheduled
Per
on our
week. Okay.
platform.
Yeah.
More than 2 million shifts per week are being scheduled on our platform. That's just for the Europe region and the US region. I haven't checked recently, but it's a big number too also. And so and our customers just love it. But finding the hardest problem we have is that first of all, we're white labeled, so people use us, but none of their end users sees they use us, right? Second of all, when we say, okay, do you want to do a case study with us? Every one of our 99% of our customers say, no, we don't. It's a competitive advantage. We don't want anybody else to know this exists. Thank you. And yeah, it's we're still working on it to improve it, but it's going well. It's going well enough today, but it's a matter of to really free the world of wasteful scaling, that everybody knows that to use technologies like this, we're definitely upping our game as we speak.
All right, perfect. So Geoffrey, where can people find more about you and Timefold?
Timefold.ai, that's the main website. And if you want to know more about the open source solver, go to solver.timefold.ai. That's the web page completely dedicated to the open source parts of it, although you will find the documentation on the main website too. And then we also have app.timefold.ai, where you can find our REST APIs for field service routing, for employee shift scheduling, and for pickup and delivery routing.
Yeah, I want to say, just to my closing thoughts and comments are, it's fascinating in a way that you've come from the development side and along the way picked up some of the operations research, but at the core of it, it really does sound like your tools company. That's arming developers, skilled developers, with a kind of tool set that happens to include a solver, as well as the APIs, some of the representations. And that's a really rich lesson for the OR community. We'd like to see ourselves as algorithms people, but in the end, the algorithms increasingly are embedded in live systems. And the ability to get those in, keep those stable, make them explainable, make the performance traceable, all of that is sort of where we're going to win or lose. And so I think this has been a great discussion and a great lesson for our audience.
Thank you.
Yeah. Thanks for your time, Geoffrey.
Thanks, Geoffrey. This was terrific.
Thank you.